All right, so last week we covered the 17th century and some of the political changes and as countries expanded. And this week we'll talk about some of the different changes in thought that will be happening throughout a longer period of time. And we'll actually cover two different eras in this unit. One would be the scientific revolution, and the other one will be the Enlightenment. So, first, we'll start with the scientific revolution. So, once again, hopefully, you've gone to the notes and you've opened up the note file. So, you can go ahead and begin with this first section today, the scientific revolution. The scientific revolution. Now, even though this would be a revolution, it's just change. It's not like science failed to exist in the past. It had. In fact, medieval science had existed, mostly built upon observations that people made, what was right in front of them. And of course, they focused a lot on Aristotle in particular and his thoughts, not really challenging a lot of what had been established in the past. And they concentrate on fundamental elements such as alchemy and the belief in keeping a balance of the fluids of the body, which is what led to bloodletting. Mm-hmm. Well, it was believed if you were sick, blood, which particularly ran hot, you had too much of, like if you had a fever, so they would make cuts in you and let out some of your blood, hoping that that would alleviate the problem. But usually it ended up hastening people's death instead. So, yes. Yeah, they were just doing, it was a lot of guesswork. It was a lot of guesswork. And actually, the church helped keep a lot of this in place because, remember, they kept the old Western knowledge. This is the way it is. This is accepted. And so people just didn't bother to question it. And it was actually the church that would inadvertently help start the scientific revolution. And the main reason why is important to the church and all of their holy days would be an accurate calendar. And of course, there wasn't an accurate calendar. The Julian calendar failed to take in an accurate revolution of the earth around the sun because, remember, back then they didn't think that was what was happening. And so eventually they had Nicholas Copernicus. Nicholas Copernicus, who was a faithful Christian, but also a good mathematician. Well, today it might be thought, especially what happened to Galileo, that it was impossible to be both, but in fact, it was quite often the case that these scientists were Christian. The mathematician knew that it needed, in order to make a more accurate calendar, we needed to study the stars and astronomy better. And he knew that the old system, which had been based on Ptolemy, which is spelled Ptolemy, Ptolemy, Ptolemy. The old system, which was based on Ptolemy studies, this old system had the sun rotating around the earth. And he quickly discovered through some of his studies that it was, in fact, the other way around. It was the Earth that moved through space, or the heavens as they would have called it back then, instead. The system where the sun is at the center and the planets rotate around it is known as the heliocentric model. Yes.
But the sun is also moving.
It is, yes. They weren't that far ahead yet, though. It was one step at a time, baby steps. The heliocentric system, the sun is what the planets rotate around. But Copernicus really didn't force it that much, and it would be others that would contribute eventually to his continued studies. One would be Tycho Brahe. Tycho, of course, is spelled Tycho. How else would it be spelled? And Brahe is Brahe. He offered kind of a compromise model that the planets did orbit around the sun, but the sun still went around the Earth. He wanted to avoid any of the theological questioning that could come up if the Earth was no longer the center of the universe. One of his students, Johann Kepler, Johannnes, Kepler, Kepler. Johann Kepler believed that mathematics could be used to explain all of nature.
Yeah. To explain what?
All of nature.
Everything.
Yes. But of course, the most famous of the scientists that would follow Copernicus would be Galileo Galilei. Galileo, Galileo. Galilei, Galilei. Galileo Galilei. His work continued to concentrate on the fact that it was the Earth that moved throughout the heavens. And of course, he would also use math and astronomy to prove this. He also developed tools to help him prove this as well, including the telescope. Mm-hmm.
He invented it by himself.
Yep.
Was it one of those giant dome things?
I don't think so, no.
Was it handheld?
I believe,
Binoculars.
or hand controlled at least. And he would use this to observe not just how the Earth moved through space, but also sunspots, craters on the moon, and the moons of Jupiter.
It's not even crazy. He was looking at the sun.
As Galileo continued to write about how the Earth was not the center of the universe, church officials cautioned him from going too far. When he continued to press his ideas, the church eventually charged him with attacking its authority. Galileo was eventually charged with heresy.
Now which church?
The Catholic Church, yeah. And don't be too inspired by Galileo, because he made a deal to avoid execution. He agreed to recant his beliefs and be placed under house arrest for the rest of his life.
We're still respectful. I mean, come on, you could have just been like, "Oh, I'm gonna be a martyr for my beliefs." Wow.
That's dishonor.
Yeah. Honestly.
That's a scary cat.
Who cares? Let him live. I still respect him. 'Cause
Yeah.
he's pretty cool.
He should have gone down with his beliefs.
That's right.
I mean, it is what it is.
But this, of course, signaled that there would be conflict between religion and science. But as time went by, the need for scientific discovery expanded beyond the need for a better calendar. A lot of things had happened, such as the discovery of the New World, finding new types of plants and animals that no one thought existed before, the creation of the printing press, which allowed ideas to spread rapidly, including information, and then, of course, humanism, which allowed people to reevaluate some of the ancient teachings. And then, of course, the Reformation, showing that the old Catholic Church and its ways were not the only path. Yes? Oh, no.
What was the first time a European saw one?
Oh,
That's a
That
good
would
question.
poke a giant hole, because I can understand why they think they're so special.
Then, of course, all this new information and reevaluation of ideas wasn't incredibly organized until Rene Descartes came along. What's that?
Is it Descartes?
Yeah.
Oh, I can see.
It's spelled Rene. Last name is Descartes.
Amelia Earhart, is her name? Well, not blue.
That is a pilot from the 20th century, yes.
Amelia, what's her name? Amelia Earhart.
Yeah. Anyway, Descartes brought about the idea of questioning knowledge, because a large body of knowledge that they had from the ancient days was incredibly flawed. And so he started to basically say, why should we believe all this information that we had from before? In his book, The Discourse on Method, he developed the idea of systematic doubt, questioning information that came before you. He would begin by questioning everything in existence, including himself. And he reasoned backwards from there, thinking, well, if I can think about doubting myself because I have thought, I must in fact exist. And that's where he came up with his famous phrase, I think, therefore I am.
Really?
Yeah. From there, he came up with what is known as the deductive method, using propositions to prove something to a final conclusion. So using evidence, basically.
Who is this?
This is Rene Descartes.
You said he.
He, yeah.
Renee.
Yeah.
Oh.
And he too concentrated on mathematics in particular, looking at the world and the universe in mechanical terms. And lastly, let me finish today with his opposite, which would be Sir Francis Bacon. Sir Francis Bacon. He had been involved in governing. He had been Chancellor of England. So, like many people from this time period, he dabbled in different types of studies, but he also concentrated on science. He too, like Descartes, believed that we couldn't move forward until we cast off all the doubt about past knowledge. And he focused a lot on the inductive method. This meant that through observations, you eventually come to a conclusion with the highest probability. And he also focused on building the scientific community, particularly people working together through correspondence, writing to each other, but also in institutions, combining their efforts into one.
I wanted you to repeat what you said after that through observation.
Inductive method was through taking observations and coming up with a conclusion with the highest probability. So when a weather person says there's a 70% chance of rain, that's using inductive reasoning.
What about deductive?
Deductive reasoning would be if there's a giant squall line coming towards you and saying, oh, it's going to rain any minute now. That is deductive reasoning.
You're not guessing.
Right.
You're just saying.
Yeah. So we'll go ahead and stop there. And the other thing that you can work on today, of course, would be the reading for the unit. You can see both of the tables are posted for Chapter 6 and Chapter 9. You only have a few pages for each. So make sure you take a look at the pages that you were assigned and follow the directions to enter in the information as required.